Welcome to Sine Law. So hopefully right now you have done the activity and realized that something really interesting happens even when you're working with non-right angle triangles. So the side length and the sine of the angle opposite that side length is going to be exactly the same for each angle on your non-right angle triangle, which is a really interesting discovery, because that means that we can use that new kind of ratio that we've unearthed to be able to solve for the pieces that we need. So remember that we're working with non-right triangles. If you are given a right triangle, go back to SOHCAHTOA. Also, if you're working with Sine Law, you only need to use two of the fractions, okay, or parts of Sine Law. Okay, kind of comes in three parts for each side and angle pair, and it you only need two of them. Okay, so you don't need to worry about this whole big thing. Also, you don't need to memorize this. Write these guys down on your study card, and then you'll have access to them whenever you need them. It comes in two forms. We can always take that ratio that we get from dividing side lengths by angles, and if we flip it, if we get the reciprocal of it, then we can work with it this way also. Okay, where the side lengths are at the bottom and our unknown angles are at the top, or our known angles are at the top. Okay, I want you to be comfortable with using either of these, but to be strategic, I use this form when I'm looking for a side length. Okay, and I use this form when I'm looking for an angle. Okay, so, and I always try, just because it makes the math simpler and I can just kind of follow the same steps over and over and over again, I always try to put the unknown piece that I'm looking for in this top left-hand corner. It's not necessary, but I just find it a lot easier to set everything up if I do that. And because, remember, these pieces are equal to each other, we can rearrange them however we want. And it doesn't matter if our triangle is XYZ instead of ABC. We can substitute in whatever we need to. But what I do want you to see also is we use Sine Law when we have what I call a known pair. And that's just shortcut for saying that we have an angle size and we know the length of the side opposite that angle. Okay, and I just call that a known pair. So a couple of other resources like to label triangles according to the kinds of information that we get. So you might, if you Google this or look at other people's videos, you might see that Sine Law works for SSA triangles and ASA triangles. And what that means is you're given a side, and an angle, right? If we read this kind of left to right, this is an SSA triangle. Of course, the angle that you don't know could be here, but then that spells an ASS triangles, and you know, math textbooks like to avoid that kind of thing. I think it's hilarious, but they also create some very tricky triangles to work with, but we're going to skip those kind of triangles in this year. We don't need to worry about ambiguous case. So you might come across ambiguous case if you're looking on other resources, and those will be for SSA triangles, but we're not going to worry about that this year. The other angles you might, or the other triangles you might see that work for Sine Law are ASA triangles, where you're given an angle, a side, and an angle. And I don't want you to memorize these. I don't want you to even really worry about them. What I want you to see is we have this known pair. Okay, I'm going to just get rid of this guy here. If we have an angle pair, you know, an angle, and we know the side opposite, we can fill in one of these ratios. And then if we have one other piece of information, then we can solve for the missing piece in a second ratio. Okay, and our ASA triangles here too, you'll see that we have this pair here. Okay, so we have this angle and its opposite side. We have that information. If we're given that information, then we can use sine law. So what's it going to look like? Well, the first example that we have in our notes is worked out for you also. These videos now are just going to be to give you a chance to kind of hear it talked through. Okay, sometimes it's hard to read through math and really see the things that we need to see. So I'm just going to talk you through the example that's already in your notes. So let's take a look. Can we use sine law for this guy? Well, we can, because we have this angle here, right? We have angle B and we have little b. So this is little b. Remember, little b is opposite of angle B. Because we have that known pair, then we can use sine law. We have enough information to use sine law. And we're looking for a side length here, right? We're solving for little a. So because we're looking for a side length, we're going to use the form where the side lengths are on top. Okay, we're only going to use two pieces. So the pieces we have, we're looking for little a. So I'm going to put little a here, and that means sine a goes down here. And then little b and sine b. And again, remember, we only need to use two pieces of those three pieces for sine law. So we write our formula, we show our substitution. A is what we don't know, but we do know that angle A is 56 degrees. So this is going to be sine of 56 degrees is equal to little b, which is 40 meters, a very big triangle, over sine B, which is sine of 71 degrees. Sine of 71 degrees. So we need to solve for A, and there's a couple of ways you can get there mathematically. We can evaluate this side and multiply, right, turn this into a number, and then multiply both sides of the equation by sine 56 to move sine 56 up and out of there. I don't, for some reason I just kind of do these guys always the same way. If the thing that I'm looking for is up in this top left hand corner, you might remember from our last unit on rates and scale, we can always use kind of a cross multiplication. Sine 56 times 40 equals A times sine 71. So I'm going to write an extra step in here that I normally write here. I'll write it beside here. So A times sine 71, right? This cross multiplication only works when there's an equal sign here, equals sine 56 multiplied by 40. And that's a little bit kind of easier to see what we do next. Now what we're going to do is we're going to divide both sides by sine 71. Okay, so then we're left with A equals sine 56 times 40 divided by sine 71. And this here, this is a step you can kind of ignore or you can kind of work past. And what I hope you see is if we keep our unknown, the thing that we're looking for in this top left-hand corner, then we can, it'll always be equal to the cross multiplication of these guys divided by this piece here. Okay, it'll always just work out like that. It's just how the algebra plays out. So we're always going to get something that looks like this. And we need our calculators. Remember, our calculators are in degree mode. So sine 56 times 40, and I always like to put an equal sign into my calculator at that point. Once I kind of evaluate the denominator or the numerator here, because I find that different calculators work differently. It's not a big deal here. It just gives me a little bit of peace of mind that I'm doing good order of operations. So this is sine 56 times 40, and I'm going to divide it by sine 71. And I get little a is equal to 35.07 meters. And I go back and I look at my triangle, and that is a very reasonable size for A. Okay, it's well within the ballpark. If little b is 40 meters and it's across from this biggest angle here of 71, then little a being across from 56 degrees and being 35 meters long is very reasonable. We can also find an angle size using the same procedure. If we look at triangle DEF, we can see that we can use sine law because we have this pair here, right? We have angle D at 58 degrees, and we have little d, which is 12 meters. And again, it does not matter that this triangle is DEF instead of ABC. Those ratios still work out to be the same. So in this case, we're going to look for angle F. So we want to flip sine law over, and again, just use the two pieces that we need to use. Get that in focus for you. Okay, so we're looking in this case for sine F over little f is going to equal, and then our known pair is D. So sine D over little d. Okay, that's the ratio that the formula that we're going to use to solve for f. We can't solve for f straight off. We have to solve for sine f first. But we're going to start here by kind of setting it up like this, and then we're going to substitute what we have. Sine f over little f is 10 meters, right? We can put our units in at the end so it doesn't kind of mess up our formula. Sine d is sine of 58 degrees over 12 meters. Okay, so the unknown that we're looking for is in our top left-hand corner of this structure. So when we want to isolate it, sine f is going to be this cross multiplication. So 10 times sine 58 divided by the piece of this cross multiplication that's left over. It's 12. All right, let's put this in our calculator. And in this case, remember, we're solving for sine f, so we need to do an extra step to solve for angle f. But sine f is 10 times sine 58, and again, I just like to put an equal sign there. You might want to use brackets. Okay, instead put the whole numerator in brackets first. I'm just going to put equals divided by 12. And sine f equals 0.7067067467468, and it goes on and on and on and on, but this is what our calculator gave us. We're not solving for sine f, we want to solve for f. So f is going to be the inverse sine of all of that stuff up there. Keep it all in your calculator, and at this point just go inverse sine, and for me, my calculator wants me just to use the answer key. And f then, move this out of the way, f we're given equals 40, whoa, I looked away for a second and things got weird. Okay, 44.9675, so I'm just gonna go 97 degrees. So now my answer is to 2 decimal places, and it's rounded correctly. And then, is that a reasonable number? It is pretty reasonable. Remember that larger angles create longer side lengths. So this angle here at 44 degrees being across from 10 meters compared to this angle being at 58 degrees across from 12 meters is really reasonable. So that's how we use sine law to find angle sides or angle sizes and side lengths, and I encourage you to try that.